All right, stop for a second. You have to take a breath with you. All right, so I haven't asked you anything yet. Hi. Does it strike you as a little difficult to hear a theory of everything that is open to everything? I mean, wouldn't a theory be a good theory? Let me just say, I have a line here somewhere. A good theory...
Better be a good line.
Yeah, I hope so. Well, I don't remember where it is, but...
yeah, you see, you have nothing against it, after all.
It seems to me that a theory that says that anything is possible doesn't explain anything. I mean, a good theory says why this is so, but this guy has just said, and these guys are all nodding, that this multiverse contains just about every conceivable, including that weirdly shaped thing that was behind you, every conceivable organization of matter, every conceivable number of dimensions, every conceivable possibility. And I say, well, okay, if that's your idea of science, then go ahead and conceive in the bathroom again, because that's not... How do you, I mean, it's too much, but I'm just interested in your opinion.
Well, now, so you get a similar problem even if you just have one universe. If it's big enough, say it's infinite, you will have all possible types of observers existing somewhere and having all possible types of illusions. So whatever measurements you make, even in a single infinite universe, you will have some observer somewhere, imagining that they are making exactly that observation. The question then becomes, how can you test theories if all the theories you are comparing each predict that for any possible observation you make, there will be some observer making that observation? It seems that the theories are consistent with all possible observations. So this is the problem, and the solution must be to consider not just whether a theory says that a given observation will be made, but what the theory says about the frequency with which these types of observations will be made. So you'd have to think about, if there are all possible types of observers making all possible types of observations, the interesting thing is, what will most observers see in a given type of universe?
You're supposed to be scientists. So, as scientists, aren't you supposed to try to find some way to examine your theory? If the universe that you want to check ours against is rushing at more than the speed of light in some other direction, how will you ever know?
That's a great question. But one thing that is worth emphasizing, too, we did describe that these bubbles...
Whenever you say that's a great question, you never mean it.
No, I really do. I really do. So we've been describing that these different universes are rushing apart really quickly. And that's sort of the generic case. But if two of these bubbles are really close when they're created, they can slam into each other. And if they do slam into each other, this could leave little ripples on this radiation that we've been talking about, this microwave background radiation. So there are people looking for these ripples, and that could really give evidence that we were slammed into by one of these other bubble universes. So it's not that it's completely beyond the ability to test these ideas.
Let me stick in one more idea here. People are sort of used to the idea that there ought to be one universe. So if we're talking about many, it seems like we're being very fanciful. But let's think about it, really. If we think of all the nouns in the English language, all the nouns you can find in the dictionary, how many of them are there just one of? Or does anybody anticipate the idea that there might be just one of? I know of only two nouns that could fit that bill, and that is God and universe. So if you want to have a scientific concept of the universe...
I'm so wishing I could come up with something.
If you want to have a scientific concept of the universe, do you want to put it in the same category as God or the same category as planet, galaxy, cluster of galaxies, etc.?
If you want to be unsettled, then let's turn to the silent one here, to Nick, because his idea has got to be the most bizarre in the house. And I don't know how comfortable you'll be.
I'm not sure I want to claim that honorable position.
So, the thing is called the problem of what is called the simulation argument. So I'll sum up and you explain that is. You believe that it would be possible for a universe to be simply a staggeringly successful computer that imagines a universe so perfectly that anyone in the simulation, like a character in the Matrix, that in that little blubby brain, would have an experience that seemed utterly real. So I could go, ooh, and I would feel my skin, and I'd feel the texture of your, and this would all be a computer simulation. So you propose that some civilization could build a machine?
Right. So a lot of people have proposed that as a possibility in the whole premise of the Matrix or anything like that, is that just as we can build simple virtual realities today with simple simulated creatures living inside them, maybe in the future with vastly more powerful computers, you could build more complex virtual realities with more complex simulated creatures inside them. Maybe these creatures could be complex enough that they would actually have brains like ours simulated down to the level of individual neurons and synapses, such that the inhabitants of these simulations would be conscious. But what the simulation argument adds to that is that instead of just stopping at the question of how could you ever prove with certainty that we're not in a simulation ourselves, the simulation argument tries to establish a constraint about what we can believe, and it tries to show that one of three possibilities is true, although it doesn't tell us which one of them it is.
Okay.
Now, in a sense, this sounds more radical even perhaps than some of the multiverse theories that we've heard, but in another sense, it's less, because it doesn't presuppose any unknown physics. So we're just assuming that it will be possible to build computers that are much more powerful in the future.
I mean, I think they could be very powerful, but if I thought I was in a computer simulation, I would watch your face really closely, because maybe there'd be a skipped frame, and you go, and I'd notice that.
Okay. So we can come back to that. I mean, so I get these people writing to me, and anyway. So what the simulation argument tries to show is that one of three possibilities is true. The first one is that almost all civilizations at our stage of technological development go extinct before they become technologically mature. Technologically mature meaning having developed all those technologies we can currently show are physically possible, given only uncontroversially obtainable physics.
So they make a radio, they make a rocket ship, they make a bomb,
Yeah,
they
you
die.
could build big computers the size of planets and stuff. We can calculate what performance they would have. We can't build them now, but maybe 1,000 years from now, people will build them. So first possibility is people at our stage, they just fail to get through to that level of technological maturity. Maybe they destroy themselves on the way. Second possibility is that almost all civilizations that do reach technological maturity lose interest in creating these kinds of ancestor simulations, as I call them. These would be detailed computer simulations of people like their historical predecessors. So they have these powerful computers, they have the ability to program them, but they have better things to do with their computers and their time.
Okay, here comes three.
Right, and the third possibility is that we are almost certainly living in a computer simulation. And the argument, in its full version, it requires some probability theory, but the gist of it can be grasped quite simply and intuitively. So if you imagine that the first two possibilities do not obtain, that means some non-negligible fraction of civilizations at our stage do reach technological maturity, and some non-negligible fraction of those are interested in creating these ancestor simulations. They devote some non-trivial fraction of their resources to this end. You can then show that there would be many, many more ancestor simulations than there would be original courses of history, because
why would there be more simulations?
Because if you calculate the computing power that a technologically mature civilization would have, and the computing power that would be required to simulate all human brains, it turns out that the latter quantity is a tiny, tiny fraction of the former. So, in other words, by devoting a tiny fraction of their computational resources to this end, they could create astronomical numbers, billions and billions, maybe not infinitely, but a lot smaller. I mean, to the point where if you have the ability to use some advanced form of nanotechnology to transform planets into computational systems, by using just one planetary computer, just a millionth of its computing power for a tiny fraction of 1 second, you could run many, many courses of simulations of human history. Over time, there would be more simulations.
How do you wake up in the morning?
Well, so to conclude the little arc of the argument, so if you assume that the first...
You have to. That's the
If the first two are false, the first two assumptions, you then reach this conclusion that there would be many more simulations than originals. And if almost all people with our types of experiences were simulated rather than implemented in basic level reality, we should think that we are probably one of the typical people, the simulated ones, rather than the very exceptional ones that were part of the original history.
Well, I have a feeling, how much time do we have left? Are we getting up on it? Is it like, are we supposed to be out
Depends
of
on when we're supposed to.
Okay, because I don't know whether, I don't see anybody going like, stop, so good. Then collectively,
It's morning in China.
do you guys feel that a multiverse concept in which is this array of possibilities, including his rather dour possibility, that if you think of the universe or the many universes in this way, do you feel that it's beautiful, or do you feel that it's to use the Copernican principle notion, that it makes us much smaller, perhaps not even real?
Yeah.
I mean, it's a very diminished state you have left us in, I think, this idea that there's so many. I liked it better with one because, you stood taller in that concept.
Oh, my God. I didn't think that I will come to it. Okay. Well, did you? No. Did you read Bhagavad Gita? I'm sorry. Okay. So one of the famous books of Mahabharata, Bhagavad Gita. Okay. And there, there is this story how some famous warrior, he actually he speaks with Krishna, and he asks Krishna, "Can you show me a universal form?" And no, I will not do it. But please, please show me your universal form. And then at some moment, Krishna tells, "Okay." So he suddenly shown his universal form, and that is the God who eats everything and destroys everything and gives gifts to everything. And he is also a lion, and he is also a tiger, and he is also an elephant, and he is everything and waves involved. And then the Arjuna who was speaking, said, "Oh no, please show me your normal face." Okay, so this is right now the situation. Just nature is much richer than what we previously thought about it. But each step when we learn more, it is more beautiful. It's actually absolutely exciting. It's exhilarating. You're trying to find it all. And then, yes, when you look at it, it's some kind of dangerous. You look at the face of it. You do not understand what it is. Oh, no, let me do something else, let me do something. So many people go to finance.
But that didn't work out for them.
See, that's why inflation in our theory is much better.
I can't think of a better way to end this thing than right there. I want to thank all of you for participating. If you have a final word, feel free, but I think that was pretty good. So thank you all for coming, and thank you.